Look around you. The smartphone in your pocket, the servers powering the internet, the artificial intelligence shaping our world. We live in a digital universe driven by code. Yet, the visionary who predicted this age lived long before the first silicon chip was forged. She was born in the era of the horse and carriage, a time when the world was lit by gas lamps and driven by steam. The year is 1815. Augusta Ada Byron was born into a psychological storm. Her mother, Annabella Milbanke, was a highly educated woman with a strict devotion to mathematics. Her father was Lord Byron, the most famous, flamboyant, and scandalous poet in all of England. Their marriage lasted barely a month. Annabella fled with her infant daughter, and Byron left England shortly after, never to see Ada again. This left Ada to grow up in a tug-of-war between her mother's demand for cold logic and the inherited imaginative temperament of the father she never knew. Terrified that Ada would inherit Byron's unpredictable madness, Annabella enforced a relentless educational regimen. In an era when young noblewomen were taught music and how to pour tea, Ada was fed a rigorous diet of logic and science. Math was intended to be the antidote to poetry. But the regimen didn't suppress Ada's imagination, it gave it a structure. At age 12, she decided she wanted to fly. She approached the dream scientifically, studying bird anatomy and examining the properties of silk and feathers. She eventually designed a steam-powered flying machine, producing an illustrated guide she called Flyology. She had successfully merged her mother's discipline with her father's vision. This hybrid perspective, the ability to see the beauty within the numbers, is what she later called Poetical Science. In 1833, a 17-year-old Ada met an eccentric inventor named Charles Babbage. He was the Lucasian Professor of Mathematics at Cambridge, a title once held by Isaac Newton. Babbage was working on the difference engine, a massive mechanical calculator. Most guests at his society parties saw it as a clever, entertaining toy, but Ada was mesmerized by the mathematical principles turning the gears. Babbage soon moved past simple calculation toward a much more complex ambition, the Analytical Engine. Conceived a century before the modern computer, it was designed with a central processor, memory storage, and programmable punch cards. Babbage was a brilliant engineer who understood how to build the brass and steel. However, he struggled to articulate the machine's ultimate potential, creating a conceptual vacuum that only Ada was equipped to fill. In 1842, Ada translated a French article about the Analytical Engine. At Babbage's suggestion, she added her own extensive notes, which grew to be 3 times longer than the original text. Her most significant contribution was Note G. To demonstrate the engine's power, she outlined a highly complex, step-by-step sequence of operations for the machine to calculate a series of rational numbers, called Bernoulli numbers. She detailed exactly how the punch cards are fed into the machine, how memory stores variables, and how results loop back into the equation. As a rigorous, executable process, it stands as the world's first computer program. Babbage viewed his invention as a supreme mathematician, a machine to crunch numbers faster than a human. Ada's insight went further. She realized if a number could represent a non-numerical value, like a letter of the alphabet or a musical note, the engine could manipulate any data governed by rules. She even suggested the machine could one day compose elaborate music. By identifying a machine could process symbols, rather than just quantities, Ada described the shift from calculation to computation. She envisioned the modern software industry a full century before a single computer was built. Her vision remained a theory because the world she lived in couldn't build it. The Victorian era lacked the precision engineering required to manufacture the thousands of parts Babbage's engine needed. Ada's final years were marked by a tragic decline. She fell into massive debt trying to apply her mathematical genius to betting on horses, hoping to win enough money to fund the engine's construction. Plagued by uterine cancer and financial ruin, she died on November 27, 1852. She was 36 years old, the exact same age her father had been at his death. Her work was largely forgotten, as Babbage's engine was never completed. Her visionary notes gathered dust, remaining unfulfilled instructions for a machine that didn't exist. History finally caught up nearly a century later. During the Second World War, the young mathematician named Alan Turing began conceptualizing his own universal computing machine while working to crack the Enigma code. Turing discovered and read Ada's notes. Her work influenced his own landmark papers on artificial intelligence, where he even addressed her specific observations on the limits of machine thought. Her theories transitioned from the margins of history into the center of the laboratory. Mechanical gears gave way to vacuum tubes and then transistors, scaling her initial logic into the massive digital architectures that define the 21st century. Today, her name is synonymous with the dawn of computing. From the Ada programming language to Ada Lovelace Day, we recognize her not just as a programmer, but as the visionary who saw the infinite possibilities hidden within the gears.